There we go. All right, so we'll just start on lesson 16. Okay. Lesson 16. Okay, we'll just go to part 2. Okay, so we had to open the file, class survey, and then create a pie chart, and then post it. Did you guys do that?
Yeah.
Yeah. Okay, awesome. And we know how to do that.
And then the
And then
bar
the next
graph.
Yeah. Everybody did that? No problems?
Yeah.
Okay. And then Charity, do you want to do the next one?
Okay. So show at least 5 ways, or do you 9?
What?
It says
Just
show at least
just
5
say
ways.
what you did.
Oh yeah, just say what you did.
Graphs and numerical statistics to describe the data above. Okay. So it wants and the statistics. Sorry, I just got started on this. So like
No, that's
why
okay.
I'm late, because we're moving. Like I am literally in the middle of packing up my house and moving it. And I was like, shoot, I haven't.
Oh wow.
That sucks.
Yeah, that does.
I have to be out by Thursday.
Ooh.
Yeah.
Ooh.
So. So I guess just the graphs, and then the numerical statistics. What did it want? Just like.
So you could do counts like of the different groups, like there are 8 freshmen, 75 sophomores, 59 juniors, 39 seniors, and 2 others.
Okay.
Or you could do the p hat, like just those numbers, the proportion that are in there.
Yeah.
Or you could just like use an English word for it, like, hey, this is what happened. This is the way the data is. It's super boring, and I am super uninterested in it.
All right. Well, we'll just move on to the next one. Okay, so 7% is the true unknown percent of the population that do not have traditional phones and instead rely on cell phones. A random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, 8%, in this survey used only cell phones? What is the mean and standard deviation of the sampling distribution based on 750 telephone users? So the mean is 7% or 0.07. And the standard deviation is 0.0093.
What I got.
Did both of you get that?
Yeah, I got that one.
Yeah. Okay.
You good, Charity?
Yeah, no, I'm still trying to, like, I just got the data up now, so.
Oh, okay. Oh.
I closed it. I was trying to do it like 30 minutes before this because it's been, yeah. So I had it up and then I just closed it, not thinking. Remember how to do all of it.
Yeah, so for number 9, you don't actually need SPSS, if that's what you're talking about.
All right, yeah, I was like still trying to figure out the last one. All right. Yeah, okay. What?
Okay.
Being crazy.
So for B, plugging it into the z-score, plugging it into the equation to find the z-score, I got 1.073.
Yep, me too.
And then plugging that z-score into the normal probability applet, I got an area of 0.1416.
Yep, same here. All right. Well,
Yes.
perfect. See, that one's like simple.
Yeah, it's not super difficult.
All right, so let's just go to the quiz.
Sounds good to me. Okay.
All right. Okay, so are you guys both there?
Yeah, I'm just
Yes.
getting it now.
Okay.
Yeah.
So you got it. Okay. It says in a
Yeah.
pie chart, why are the slices different sizes? Slice is random. The size of each slice is determined by the number of categories. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category. That one's it.
That one's it.
Yeah.
Okay. I could do the next one if you want me to.
Yeah.
Is how are bar charts and Pareto charts related? So the answer is Pareto charts are constructed from tossing a coin. They are identical. No. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest. That's the right one.
Yep. Perfect.
Okay. So question 5, use the following information for the next 3 questions. We conclude that p hat is normally distributed. English is difficult.
Yeah.
If np is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Question 5, is p the true proportion or the sample proportion? Oh, gosh. This is where I always get confused.
I know.
I believe it's the... I'm going to go look that up
I think
because
it's
I'm super
the,
confused.
uh,
I believe p is the sample proportion.
So P,
Yeah, that's what I was gonna say.
yeah, I'm like looking at my notes. I think it's a sample proportion.
Yeah. I believe
Well,
that's...
Wait.
No, I think it's the population proportion,
No,
and then the P hat is a sample proportion.
Yeah, the p hat is a sample proportion. Yeah, it's the true population
Yeah.
proportion. It's on our individual prep assignment.
Yeah. I
Yeah.
just closed into that.
Okay, so then what is n? So that's the sample size.
That
Yeah.
one never changes. He always gets a different thing.
Thank goodness, right?
Exactly.
Okay, so then it says if P equals 1/4, what is the smallest n that satisfies the requirement? I guess
Oh, you have to do
I
the,
just do this equation.
we have to do the equation.
yeah.
So let me get a piece of it. All right.
So you do the p times 1 minus p, that one? Or which one do you do? I'm confused now.
Let me ch-
So do we do the one that's like n equals like the thing in reverse? Does that make sense? Or do
We
we
could. We
just
just have to figure out the z-score if we're doing No, sorry, using different ones. That's where I get when I look at three different equations.
Yeah.
Okay. So p hat equals x over n, but that's not the same thing. Oh, here we go. Okay. Well, how do you do that? Do you do like 10? I don't know what you're supposed to do then. Okay.
I'm just trying to see. Why don't you just do
10.
that n times p is greater than or equal
Well,
to
yeah.
equation, and then just have
Do you
n
do 10 divided by 1/4?
equals
So it'd be
n
4.
equals 40. Let me see. I'm going to use those two equations that they gave us and see if that, because I think like that makes sense to me.
40? Is that what you got?
Yeah, because if you just, and then let me just check it with that equation, the other equation.
Yeah, that's what I got too. So the other equation.
I'm thinking it should be like 40 times 4.
So 40 times 1 minus 1, 4.
I mean, that right.
Yeah, well, it's greater than 10.
It
Yeah.
is much greater than 10.
Yeah, so is it supposed to be smaller than 40 then?
I know, that's what I'm thinking. Like,
If it's much greater than 10. Let's see. I'm just going to try different numbers.
well, I don't think it would be because if you did like even 39 times 1/4 p, then your n, or that won't work because it won't equal. Like if you do the np is greater than or equal to 10, if you plugged in 39 p and your p is 1/4, you're gonna have less than 10. So even though
Yeah.
in the
Okay,
other
yeah.
equation,
So it's 40.
like it's a big number, anything less than 40 is gonna be less than 10.
Yeah. So it has to be 40. Okay, cool. All right, so the next question, what is the mean of p hat? So that's just 0.4, right?
It's what? You cut out right there.
It's just the 0.4, right? Or is it something else?
That's what I understand it to be.
Wait, let me check. Because I think it's 0.4 divided by 24. If I remember right. That's what I wrote.
Well, in the individual prep.
P hat equals x divided by n. That's what I'm thinking. X is this. So BP.
Oh, because it's p
0.4.
hat.
I was
Okay.
thinking something. Yeah, I'm thinking something different. So it is 0.4.
It is 0.4?
Yeah, I was
I believe
thinking.
so because P and P hat, I think in this case, are interchangeable.
Yeah.
Oh, okay.
No, I was thinking something different that I read. I got mixed up.
All right.
This equation. Uh-huh.
Okay, then the standard deviation. Okay, one is
So this one is the square root p times 1 minus p over n.
Yeah.
Yes.
So
10 squared. 0.4.
4 times minus 0.4. 24.
Over 20.
0.01 and the square root of that.
What'd you guys get?
I'm still rocking an equation now.
0.1.
Okay, that's what I got too.
Yeah, that's what I got.
Okay.
Okay. Cool.
All right. So is it turn now? All right. Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100 at bat. So n equals 100 and p is 0.3. What is the p? So the equation we just did. 3 times minus 100.
So the P would just be 0.3 then, the P hat. Same thing.
Yeah.
P would be 0.3 or yeah.
Okay.
Oh, I'm getting confused. Okay, yeah. I'm overthinking again.
8.3 times 1 minus 0.3 divided by 100. Okay, so I got 0.046.
That's what I got.
Yeah, I got that as well.
0.046. Okay, cool. All right, then what is the z-score? 0.046.
Okay, so if P and P hat are the same,
That
then the
can't
Z
be. The z-score
the same.
equation is different.
Yeah.
So p hat equals x over n. We have to figure out what x is. What is x?
X is the number of individuals. It says.
Wait, it's in the word problem.
Oh, okay, so x divided by n. Number of individuals. Oh, okay. So number of individuals.
5.
Yeah, is it 35?
Makes sense.
I'll go with that.
If N is
Yeah.
100 and you're wanting to know if she's going to get 35, then I would think it's 35. Because it says, like in my notes, off of like video, X is the number of individuals with a certain characteristic. So 35 is technically the number of times she actually is hitting, if that's what we're looking for. That makes
Okay.
sense?
Yeah.
So it'd be
So the
35 divided by n is 0.35.
Yeah.
so that's the p hat. Yeah, so do we have to
So the one above will have to go up and look at that one as well. Because I already have all this in my calculator.
well on the individual prep, it says that P is the true population proportion, which is also the mean of the distribution of P hat. So I think when it's asking for the mean of P hat, it's the same. So
Okay.
it's just the 0.4, but when it's P hat, then it changes and we actually use the equation.
Okay.
Yeah, because question 10 is different than question 8. Because what is the mean of p hat is question 8.
Yeah.
And then question 10 is what is p hat.
Okay. Yeah, that makes sense.
So,
I mean, I guess we'll see if it's right or not, but.
it's a good thing we get to do this twice.
I know, seriously. Okay, the z-score.
It's 7.638. Is that right?
Still gonna wait.
Okay. Well, because if you're just taking question 10 divided by question 8. I did it wrong.
Okay. Value minus mean divided by standard deviation. How? Actually.
Okay, so it is 1.091 is what I get when I did it right.
0.46. So for the mean, is it 0.35 or is it 0.3?
So the wait.
Oh, it's
For the
0.3.
p-score, it's the p hat minus p, so you're going to do 0.35 minus 0.3. And then divided by
Okay. Divided by
the
the.
standard deviation,
Okay, so 0.35 is
0.046.
3 divided by 0.046. So 1.087.
I got 1.091.
Because I got 1.091, but because I didn't use I used the whole number instead of the rounded number from question 11.
Oh, okay, yeah, you have to do that. I forgot. Okay. So yeah, so it's, what'd you guys get?
1.091.
0.91.
1.09.
Yeah, it's because I used the rounded number,
Yeah.
so you're not supposed to do that. Whoops.
Cursed rounded number.
I
I
know.
know. Okay. I don't even know who we're on,
Yeah,
but
at least 35.
what is the probability at least 35 hits in her next 100 bats? Oh, crap.
Is
Very
that
good.
above? That's the above, right? Above the line on the normal probability outlet. This one always gets
Is
me
it
as
At
well.
least 35 hits.
Yeah, I think
don't know.
it's greater than or equal to.
Yeah, greater than or equal to, so 1.091. 1.091. So it'd be the center and the outer, in the right.
I think so.
So 0.862.
0.0, wait, what is it? 862. 862. Yeah. That's what I think.
Okay, what was it? Sorry. 0.082?
Um,
Or what did you
0.862.
0.862. That's what I. All right. Trying to find my. It's not.
Okay.
There it is.
All right. Who wants to do the next one?
We're working on it right now.
Okay. All right. So standard deviation. 291 minus 52 divided by 2,000.
So I got 0.011.
Divided by 2,000. What'd you get?
0.011.
Yeah, that's what I got too.
Okay. I'm still working on it. Sorry, I was reading the question. I'm still
No, it's all
No,
good.
you're fine.
catching up. Pop up on my screen. I had to clear it before I could read it.
So 0.52, 2,000. Point zero one one. Two. X over 1.
Okay, so you got 0.0. 0.011.
Yes.
Yeah. Okay, so then for the z-score, we have to figure out what p hat is, right? For the value.
Yes.
So x is it's just getting less than 50% of the votes.
Is it 0.5 over?
Yeah, would it just be 1,000 over 2,000,
That's what I would
which would be
think.
0.5?
But it's only less than, so it may be still 1,000. So we're doing. Are we getting a negative thing
I
there?
think it's
Then?
0.5.
So
Yeah,
0.52.
yeah, 0.5 minus 0.52 divided by 0.011.
Well, the wait.
Like the whole thing, yeah. So then I get negative 1.7, and then a 0.
Oh yeah, I keep forgetting to do that. Okay, negative 1.70.
790 is what I get.
So we got a negative 1.790.
Yeah, that's what I got.
Okay.
And then we put it in over here.
1.790. Okay.
And we want just less than.
Yeah, we want less than.
Yeah. So 0.037. Okay. Oh, we got one wrong.
Which one?
We got the probability Brittany gets at least 35 hits in her next 100 at bats. So maybe it's just the more then. Or no, maybe I don't know. We then. Dang
It
it.
would just be the right side on that.
Okay.
Mm.
Oh.
I'm gonna try this one.
See if it's right.
Yeah. What number was it? Yeah, it's
Number
0.138. It was number 13, right? Yeah, it was 0.138.
Okay.
I hate word problems. Ugh.
I know.
Because it's like, we're gonna do this. No, we're not. Negative Ghost Rider.
I just gotta do it all again.
Yeah.
So question 3 is each slice.
Yeah. Do question. Plus size. Forty. Zero point zero 0.05. So it's 0.137 or 0.138.
0.138. Yeah.
Okay. Negative 1.79. And then 0.03. Okay, awesome.
All right.
Well, let's go to
That's 17 here a week.
lesson 17.
I hate conference
All right.
calls.
Okay, so in an October 2008 poll, 684 of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. Find the proportion of those surveyed who have been in an automobile accident in the last 5 years. So 684 out of 1,006 is 0.6799.
Yep.
Okay.
Okay.
And so looking at the requirements for constructing the confidence interval for this data, they're significantly greater than 10.
Yep.
Significantly greater. So the
So
requirements
they are
are
met. Perfect.
I'm still trying to bring it up. I haven't done this assignment yet. I haven't had time to do this one.
it's just
Okay.
adding more complicated things to finding confidence intervals.
Of course.
Yep.
Because they like to make everything more complicated. Just as you start getting
Yeah.
comfortable.
Welcome to math.
Yeah, well, welcome to life, right?
Seriously.
Like life in general.
So true.
Not allowed to be comfortable.
So true.
Heavenly Father doesn't like that very much. He's like, no, time to grow.
Hey, you're not doing anything right now. Here's something for you to do. It's called growth.
Yeah. Yeah. Like for the rest of your life until you come back. Yeah.
And even then,
Yeah, and even then, still gotta work with stuff.
I like that the equation is slightly different than the confidence interval we had before, because it's just taking like what we just did with the confidence interval for like C. We just take the Z score, the Z star, and then we just plug numbers in, and it's just, instead of the plus or minus, it's just like, here it is.
I like that too.
So I mean, it added more, but it kind of made it less.
Complicated.
Yeah, it's like, okay, this is nice.
I haven't read through this part yet, so.
It's just throwing proportions into what we just did. So we're not using like we're not using the sample tests from SPSS. It's just like, here, if you can do some algebra, here you go.
Yeah.
Sounds easy enough.
Sounds easy enough.
Actually
Actually
love
doing
it.
it though.
Yeah. Okay. All right, so I have it up now.
Okay.
So which part are we doing? There's the part 2? Is that
Yeah,
what you
we're
guys-
doing 7
Yeah,
and 8.
part 2.
Okay. Okay, so for A, you was at what, 684? Or
Sorry, say that one more time. I zoned out. Sorry.
what did we get for A? Sorry.
0.6799. Because it's 684 divided by 1006. So that's
Okay.
0.6799.
Okay.
And then if you look at the requirements, like what we learned last time, those are still significantly higher than 10.
Can't be higher than 10. Okay.
Yeah.
And then C is just doing the, because we're looking for a 95% confidence interval, so it's 1.96 times the square root of 0.6799 times 1 minus 0.6799 over 1006, and that gets you 0.0288.
Okay. So it's 1.96 times what?
So it's 1.96, so the Z star times the square root of P hat times 1 minus P hat over N. Kind of the standard deviation
Oh, so like
equation
that
we just used.
whole equation. Yeah. Okay.
Yeah.
And then we just plug the numbers in, and it comes out to 0.0288. And so to find margin of error, we have to do the plus or minus part now. But that's taking 0.0288 minus or plus 0.6799, and that gets you 0.6511 or 0.7087,
Okay.
0.6511. So we have that really, really little area.
Yeah.
So
Okay.
we're 95% confident that the true proportion population mean P is between 0.6511 and 0.7087. I always hate the way they phrase these. 'Cause it's like,
I know.
I think that's what I got wrong on my test was not the math. It was just the stupid wording.
Yeah.
Yeah, it was the one
Yeah,
that
I
was
know.
like, we are
Didn't know what I got
95%
wrong.
confident that 95% of all the, something like that. That's the one I got wrong. To like
Yeah, it
use
was
two percentages.
It was like,
Yeah.
dang it.
Like, that's so dumb. But now
And
I'll never
so-
get it wrong because I just think two percentages. Like, that's the right one.
Yeah, that's
When that's two percentages.
so to find the number, we have to do n equals z star divided by 2m squared. So we have 1.96 times 2, not times, divided by 2 times 0.15. Okay, there's the margin. I was like, wait, I totally just forgot where that number came from. To find that, so it's 4,268.4 repeating or rounding up. 4,269. Because you always go up when you have the decimal points. You always go up to the next number, next whole number.
Yeah, because you can't have
A
like
quarter of a student.
portion of a person, and you need that extra portion of a student to have your confidence.
Yeah.
I understand. Okay, I'm gonna get my charger, my phone, or my thing.
Then the next question 8.
Ooh, I can do this one.
Interested over 60% of all students. Use the same information as above and use the level of significance of A equals 0.05. It's 0.06. The alternative is P is greater than 0.06.
Okay.
And so the z-score, the test statistic score.
Yeah.
Z-score. We do that whole stupid equation again, so it's like 0.6799 minus 0.6 over square root of that mumbo jumbo, and it equals 5.174. So that is a stupidly high test statistic, like abnormally high.
Yeah.
Your z-score is way out there, so the area is way tiny.
Mm.
And
Okay.
so the p-value is, if we round it to 3 numbers, it's 0.
Yeah.
But if we round it out to 9, it's 0.0000000115. Pretty sure we should reject the null
Yeah.
For
because
sure.
if the p-value is low, reject the null.
Yeah.
Yep.
All right.
Okay, cool.
Then we have sufficient
So-
evidence to conclude that the true proportion is all that.
Yeah.
To the quiz away.
Okay. Are you guys there?
I like not having to use SPSS for this.
Oh, nice.
But then I kind of hate it because I kind of forget what I'm doing again.
Yeah, I just got used to it. Like I finally was like last week I was like, wait, like this actually makes sense. It took me half a semester, but it makes sense.
Yeah.
Seriously. We ready to get the shindig started?
Yeah.
Yep. You want to start us off?
Okay. The symbol for true population proportion is which of the following? The Nye over the P, or the P hat, or P. Wait,
So
it's psyching me out again.
population is P.
It's P.
It's
Yeah.
P, yeah.
Yay.
The next one is the requirements for interval are satisfied. So, yeah. So n times p, p hat. So that's 100 times 0.25
40.
is greater than 10. And n times 1 minus p hat minus which is 0.75 times 100. So true.
Woohoo!
Woohoo!
Okay, so then the next one says requirements for inducing a hypothesis test.
That's supposed to be conducting.
I think it's
Yeah, I don't-
conducting. This is like way okay. Requirements for conducting a hypothesis test are satisfied. Right?
I think it's true.
I think it's the last one was true. I think so.
I would think so. Okay.
So the next one.
Okay,
Use the
so
following
next one,
information.
first-degree murder trials was.
So a random
Oh.
sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find the p hat of the point estimate of the proportion of first-degree murder defendants who were found guilty in the state. And if I remember correctly from the last lesson, it's 45 divided by 60, which equals 0.75.
What?
Mhm.
Okay, so it's, sorry.
So it's 45 divided by
So
60.
it's, don't you do x over n hat?
Yeah.
Yeah,
Yeah.
Oh, good. I'm not going crazy. I actually
and
remember.
you
what
already
I'm doing.
calculated it, so you're just saying what you got. Okay. Okay, perfect. 0.75.
It's equation time.
Okay, then we create a 95% wall. Okay, so the margin of error 5% confidence interval. So we just got to do that. All right. 0.96 times square root of p hat of 0.75 times 1 minus 0.75 over n, which is 60. It's 0.1. What'd you guys get?
if I did this correctly, I got 0.056. I don't think I did it right. I think I just did. Oh,
Okay,
I
I
just
got
did
a
standard
different thing.
deviation. Dang it.
Do that times 1.96.
Yeah.
The standard deviation times 1.1
Yeah.
or 196, right?
1.96, yeah.
Yeah. So which one is p? It's not p hat, which we just found out. That's where I'm confused.
Yes.
Which number do I use for p?
It's the p hat. It's the
It is the
7.5.
okay. I was just like, wait, because I started.
Wait a
I was like, wait, which number am I using here? Okay, that makes sense to me.
Is it 0.110?
Yeah.
0.75 times 1 minus 0.75 divided by 60, right?
Yes.
And the square root of that number
4.86. So the lower bound would be 0.64. And the upper bound is 0.86, right? So you got?
okay. That, I'm still figuring something out. Okay, so what did you guys get for the margin of error?
It should be
0.110.
0.110.
Okay, then I did something wrong.
Did you times it by 0.196?
Yeah, I just probably did something wrong with my calculator.
Yeah, probably.
Syntax. Syntax sucks.
0.75 times 0.5 divided by 60. Okay. Where are you on that one? I said I'm still not getting it. What am I doing wrong? Oh, I am getting that. I'm just not rounding it right. Because it's
I hate
like
it when that happens.
0.1095, and then I was like, no, I'm not getting it right, but it's 0.1095, so you have to round it. Okay. All right.
So you were getting it right.
I was getting it right. I just wasn't rounding it. Like, wait, I got 0.109. Okay. Okay, so then we want the lower bound and the upper bound.
It's 0.640, correct?
Yeah, 0.64. Yeah.
And then 0.860.
And the upper is
I think so.
yeah.
Yeah.
And then the next one, if you increase the sample size, what happens to the evidence interval? That's, I don't remember, honestly.
Okay, let me see. You have to think about it. Here's the
I
sample
believe it
size.
decreases.
The confidence
margin.
interval decrease.
I think. But anyway, continue on.
Decrease.
I think it's decrease. Like, I know there's two things that increase together, and the other one is opposite. One increases, one decreases. I think it's this one. You gotta think I always try to picture the map, or like the chart. And like we have that law that says if you use more numbers and it's closer to the mean, so it's going to come in closer, so it's going to be smaller, so it decreases.
So it's decreased.
I have to like go through this whole thought process every single time.
Okay.
Okay, so the next one says to conduct a hypothesis test for one proportion. Suppose p equals 1/2, one of the smallest n can be, and both requirements can be met. So we just want to find out n times p equals 10, right? It's greater than or equal to 10.
Yes.
So, um, so basically 50. Wait, let me make sure. No, I think it might be 20.
I was thinking it was 20.
It's 20. I just was like 50%. Yeah, it's 20. Yeah. It's 20.
Okay, awesome. That's what I got.
My mind is fried.
Story of
I'm moving
Okay,
an
the
entire
next one.
house, classes, and taking care of 6 kids. I'm done. All right.
Wouldn't this one be 100?
Yeah, one.
To conduct a hypothesis test for one proportion, 2 requirements must be met. So is it 100 in that one?
Yeah.
Okay. Sorry, it was cutting out. So.
Oh, sorry.
No, that's fine. It's my internet there. I'm sure it's just having problems again.
Okay, so the next one. Are you guys ready for the next one?
Yeah,
Yes.
I am.
Okay. For the water quality, about 6 quality indicator. The researchers suspect that water quality in the area has decreased. This test using significance level A equals 5 with the following hypotheses. New data in the 80 and X equals 38 indicate good health. Conditions for hypothesis tested. So, P hat.
Well, I figured out 14. What was 13? Sorry, I was doing math.
Okay.
I think I'm pretty sure 14.4.
What was 13 again?
Oh, true. Sorry.
Okay, 14 is 0.475.
Yeah, that's what I got. Find the test statistic. Okay. Score value minus mean. Mean is 0.06 over standard deviation, which is rid of 0.475. 1 minus 0.475 divided by okay, so 0.475 minus 0.6. I don't know if I did that right, but okay.
So I got negative
To
2.282.
get for the negative
2.282.
282.
2.282, yeah.
Dang it, that's okay.
Did you put p hat in instead
I-
of p?
Sorry,
supposed to do
cutting it
P
out
hat.
again.
Okay, let me see. Whoops. Oh, I did do that. You're right. Okay. So negative, or not negative, 0.1 6. So 5 minus 0.6 divided by the square root of 0.6 times 1 minus 0.6 by 80. I got 0.282.
Yeah, negative 2.282.
Yeah.
Okay. And then it says what value for that. Well,
So the p value would be, because isn't it just the left side? Because we're going for less than p.
0.01.
Yeah, I got 0.011.
0.01.
And that is significantly less than the alpha.
So we reject it.
Check the null.
This is where I get confused. I hate these because they sound the same. It's like I feel like the insufficient and sufficient, like the opposite ones, could totally work for each other, but that's just me.
Yeah, I have the hard. I have to read like
I agree.
read the problem again, see what we're trying to find, and then I'll know. So let me look at it. We're reading about
If we were to usually sufficient evidence,
water.
fail to reject it, it's insufficient evidence.
I
Yeah,
believe there is sufficient evidence to conclude that the water quality in the area has not decreased. Because reading the test, the researchers suspect that water quality in the area has decreased.
As not right.
So I will be the guinea pig on this one.
that it has decreased, right? Because we rejected the null.
Yeah.
So if we rejected it, then that we found sufficient evidence that says that yes, what we were searching for is what is happening.
Right.
So
Yeah.
it should be. So there is sufficient evidence to conclude the water quality in the area has is what I would put.
Has decreased. Yeah.
Has decreased?
Yeah.
Okay.
So I will submit my test and let's see.
We got it right.
2, 1, 1. Here we go. We got them all right.
Sweet.
Good job, guys.
That is fantastic.
Sweet.
Well, we better let you get back to packing.
Well, I
Yeah.
will turn.
Good luck.
I will turn the thing in. Yeah, and good luck with your everything. It's pretty exciting.
Yeah, it's an interesting move. I don't know. I'm not happy I'm moving from my ward, but I'm excited for the new adventure. So
I know that feeling.
and I'll have
Have a good week.
so I can deal with 115 degrees a lot better. So,
Oh, all nice.
True.
all right. Well, thanks, guys. I'll see you guys next
Have a good one.
All right, see you next week.